try to figure out what can I do, and I found out that with my background, I had a skill to find leaks in buildings. And when I say leaks, I didn't mean a toilet running. A building like this, someone would call up and say, we can't figure it out. Consumption doubled last year, and tell us what you can do. And that's what I've done for the last 27 years at Ashokan, and we developed a product we called AquaSync. I'm not here to plug it. I'm here to talk to you about water, how to use water meter reading to save water. And my first, I just want to talk a little bit about water for 10 minutes. Then I'll talk about water meter reading, why we should do it, what are the cheapest and best ways to do it. There's a lot of complicated ways to do it. And then what you should be expecting to get out of it. And afterwards, I'll break for some questions. We in the facilities management engineering community are beset with everybody talking about energy. It's all about energy. Energy is a big number. And in Vegas, water might be an important thing, but even here, it's secondary to energy. And I'd really like to, first of all, and they get lumped together. The person doing it, you're handling utilities, handle water, handle energy, handle gas, steam, district steam, and also take care of the water. It's not the same thing. They act differently. Number one, there's no room in the air to talk about anything except climate change. Well, climate change, no matter what's going on, there's losers when it comes to energy. But water, there's losers and there's winners. In South America, due to climate change, in Chile, for the first time in 50 years, their fields are blooming. The air got warmer, it's holding more water, they're getting rain. So there are winners and there's losers. And you really want to look at this. If you're worried about the environment, you want to step back and say, hey, is it really necessary? I can tell you in the Northeast, it's been raining since 2000. On the West Coast, it's horrible, and it just seems to get worse. So you really, your budget is still your budget. You're going to have to pay for the water, but whether there's an environmental issue is a different story. The other thing is, in the Northeast, we're getting storms where we're getting 100-year storms every 5 years. So everything's flooded. As a result, towns are spending more on sewer, and many of those towns are therefore raising their water rates because that's what they can raise. So too much water is actually causing you to spend more money for water. There's one more thing. If you look at energy, and I'm sure you all took on a project at some point in time where you were betting on the returns, on the savings to pay for the project. You figure, hey, I'll put a better chiller in, I'll put any piece of equipment in, and I'm going to save money. And you figured, hey, fuel is, back in the Jimmy Carter days, heading up to $5. Or, and what you found out right after you did the project, you cut consumption by 50%, and water and energy dropped 50%. Well, the good news is water doesn't spike, but it just keeps on going up. If you look at that line that just keeps going up on the side, that's water and sewer. It doesn't shoot up. And the reason is water is not a commodity. Now somebody's going to start, bottled water is a commodity. But in your town, how many of you are experiencing drought of some sort? Have they raised water rates? I mean, significantly. Like, if there was no water, you'd imagine water rates, if it was gas, would go up 75%. That doesn't happen. It goes up slowly. And the reason is you really don't pay for the water. You pay for the employees of the water company. You pay for their chemicals. You pay for their energy. You pay for other things. But you really don't pay for the actual water. And if there's a lot of water, if it was a commodity, there was a lot of water in Maine and no water in New Mexico, well, if it was gas, they'd get it there. It doesn't happen that way with water. Someone has a drought, and the next guy next door has no water, has a flood. So water acts differently. The other thing is, we know with energy that we can put in a piece of equipment and save, and see a savings with an efficient piece of equipment. Because, yes, energy can leak. You can have a gas leak, but water really leaks. And when you find out that you have a problem, you just put a whole bunch of equipment in. You changed all the toilets, you put a new cooling tower, you put a new irrigation system in, and hey, consumption went up. And then you find out you got leaks all over. Whether it's the top left, that would be your left, a cooling tower, something as simple as a ball cock falling off, dripping faucets, irrigation, or boiler tubes leaking. Any of these things, you could have done everything right as far as replacing equipment, but what you want to do is monitor leaks. And that's what we're talking about today. Okay, the good news is due to evapotranspiration, water that we use today goes up into the sky, comes back 5 years later. Eventually it comes back if we learn to live within our means. We can have enough water forever. Now, whatever you say, one day we're going to run out of gas if we keep using it, and oil. It might not be today, it might not be in 10 years, but if we keep using it in 1,000 years from now, it won't be there. I'm really hoping that there'll be plenty of water in 1,000 years if we learn to live within our means. So, it's not a commodity, it leaks, and we can come up with a plan and really live within our means. And let's get into that. I want to tell you a story of where I'm at in New York City. In New York City, in the 80s and 90s, was suffering drought every 2 years. We were using 1.5 billion gallons of water, 1.5 billion gallons. And New York City rolled out a toilet rebate program. Back then, toilets were 5 gallons. This is 95. And the federal government had said you needed 1.6 gallon toilets, but no one had them. And New York City decided to jumpstart that, and they gave, in the 90s, $240 to anyone that changed a toilet. You changed 1,000 toilets, you got $250,000, and 1 million toilets were replaced in 2 years. City water consumption, there were other efforts also, dropped from 1.5 billion gallons being consumed every single day to 1 billion gallons. It dropped a third. That's quite impressive. I had a company, a different company at that time, and I had replaced 52,000 toilets, not myself. And I started tracking all these buildings, and we saw all the buildings' consumption drop by a half. Now, we were expecting 15% drop. You know, how did it drop in half? The toilets weren't using that much water. If you figured it out, the toilets were only using 25% of the water. So and what we found, we also did shower heads and aerators. What we found was that we weren't replacing toilets using 3.5 or 5 gallons. We replaced leaking toilets that were just running. The whole city was running. And had we replaced them with 3.5 gallon toilets, we would have seen a huge savings anyway. Because what we did was replaced a lot of broken equipment. So I tracked this. And New York City offered you a choice in those days of being on metered billing, where you paid for what you used, or being on flat rate billing. It was a choice. They had a higher rate for flat rate. They still have it, about 20% more. And if you were on this flat rate, you could use as much water as you wanted. It was based on the size of your building. And what I found is after we changed the toilets, all the buildings saw consumption drop 40 to 50, 30%, 30 to 40%. 2 years later, the buildings that were on metered billing continued to drop 3 to 5% every year. And all the buildings that had done all this work that were on flat rate billing were back to where they're at. First thing the super did is people were complaining toilets weren't that great in those days. He took out the flapper, put another flapper, he told everybody, hey, it's using 5 gallons, it's working beautifully. That's what we do as facilities managers. We solve the problem. Problem was the toilet was backing up, getting clogged. Well, put another flapper in, now it works. We don't need that newfangled one. The other thing is, the boss never called down and said, hey, how come my bill went up? They were in flat rate billing. So what I found at that point in time is, if you meter, if you bill for water, very simple, if you bill for anything, people will figure out how to use less of it. Now, you want to put the responsibility for this bill with the person that uses the water. If the owner of the building, if it's a residential, huge building, and the owner's paying for the water, and the tenant is in the apartment, well, he doesn't have a great motivation to save water. So you got to make sure that the people that are seeing the pain, the bill, are the people that are getting the people getting the bill are the people that are in control and can do something about the problem. Okay, who's interested in submeters? Is everybody a facilities manager, basically? Anybody in the financial end? Okay. What we're finding is the following people care about meter reading, and they have different goals. And their goal may not be your goal when they tell you, hey, implement this program. The chief financial officer wants to get money from whoever he can. So if he has a restaurant in your building, he wants to bill them for that water. And his goal is, hey, generate a tenant bill that I could pass on to this guy. And as long as the guy's paying, he doesn't care. That's his nature. He's got to get back money from wherever he can get it. So that guy just wants to bill. Stockholders, well, they're now into ESG. If you are a publicly traded company, or even if you're a large company, they want to know what your environmental, social, and governance score is. One of the score items is water. So they have to put in a number. We're reading meters for L'Oreal at their headquarters, and they're using no water. I mean, they've got 20 toilets. They spent a fortune removing a huge marble wall that the piping was behind to put meters in, because France requires them on their financial report to say how much water they used at their headquarters in the US. I'll tell you, it's about $8,000 a year. And they're ecstatic because with the meter reading, they dropped it by 30%. So they're saving $2,000. It's not a significant number. The building engineer, well, unless it's part of a budgetary thing, he wants to know he has no leaks in equipment. He wants to know my boiler tubes are not leaking. My pumps are not spitting water. My roof tank is not, the pumps are not pouring water through the overflow late at night. My irrigation's not leaking. He wants to he uses water consumption as a tool to monitor his success on his equipment. If your water consumption is low in most equipment, probably in a boiler, you're going to see your fuel come down. It means if you have a air-cooled unit, it's not going to make a difference. Other equipment, if you're using very little water, it means your equipment's running away. Chief Environmental Officer, he has conservation goals, in many ways like the stockholder. And the engineers, architects and engineers, they designed a great product for you, and they want to know, was it successful? So they want to know ROI, they want to know return on investment. So we come down to two things. One, bill tenants, and when I say tenants, not residential, anybody I can bill, anybody that I can find a clause in the lease to bill. And two, let's catch leaks. Usually, the sink leaks you could find out yourself. It's the leak on a piece of buried equipment that you're concerned about. I want to talk a little bit about meters. Anybody responsible for putting in utility meters in your town? Or does the utility take care of it? Which towns are you? Is anybody responsible for meters? No. Okay, some towns. So the simplest meter, the meter you probably have in your home, is a displacement meter. A displacement meter, the water comes in, it goes into a device like a cup, and it moves it around to the other side and dumps it. Or there's a little propeller, but it's actually grabbing the water, taking it to the other side, and dumping it. So, it's always got to be right. The problem with it is if you have this meter, it can only go around so many times. So it's great for a house. But if you put a piece of equipment with a fast pump on it, it's not going to work. So they came out with turbine meters. That's the blue one. I think that's a census. And turbine meter has a propeller inside, a little impeller, much like the little one you had when you were a kid. You blew against it. And if you blow on, and if the water goes through, it turns the propeller. Really simple. Well, remember when you were a little kid and you had that propeller, if you couldn't blow well, it wouldn't turn. So if you put in a turbine meter on a house and they've got a drip in the faucet, it will never show up. Even if they leave the sink on, it won't show up. It needs a lot of flow. So it's great after a pump. So the water meter industry came out with a great idea, a compound meter. And the compound meter is a displacement meter, slow flow, very accurate, and fast turbine. And it put it together in one body, but now you needed all kinds of things. A little check valve that would stay closed on the high side if you're using very little water. So if you were using a little water, it sent it to the displacement meter, and if you're using a lot of water, it sent it to the turbine meter, and now it's complicated. They break. They always break. They last, but there's a lot of valves, and people don't know they break because one of the heads keeps registering. And they figure, oh, I'm using a lot of water, that's why only the high side, or I'm only using a little water. But something's broken inside and you really don't notice it. That's not bad, by the way, if it's your town's meter. Don't replace it. It's probably under-registering, and you're getting a small bill from the town, so that's a good thing. And if you got a turbine on the town, that's also good, because it's under-registering. They came out, therefore the industry, which is run by American Water Works, came out with a single jet meter. Essentially, it's a very accurate impeller that measures both low and high. And again, all of these meters are mechanical in nature. About 15 years ago, they came out with a sonic meter. If you look inside this meter there and you stare down the barrel, you will see nothing. There's nothing there. There's no moving parts. If you look inside, you'll see a little dimple, and it might not even be there. It's an electronic device. It sends a wave across the pipe, bounces back to the other pipe. So the water's coming from this side, it hits there's a wave going like that. When the water goes quicker, the wave moves quicker because it's the regular speed plus it. It's very accurate. It's expensive. A 4-inch, you're probably looking around $5,000. It seems that these prices are dropping and utilities are moving towards them. It's light. It's very light. It's easy to put in. The flanges move, so if your flanges are not set right, they're a little off, well, you could move the flange and put the bolt in, put a gasket. It's really easy. So somebody said, why do I want to put an inline meter in? Let me do the exact same thing and attach, I don't know if you can see, 2 little boxes on the pipe on the outside wall, and then I don't have to cut into the pipe. And those are ultrasonic clamp-on meters. They are more money than the other ultrasonic meters. They require somebody with a little knowledge to put them in because you have to space them. And they have one more problem. If you've ever had an ultrasound and you went to the doctor and he put that jelly on your chest with the ultrasound, and the jelly dries out on a pipe after a few years, especially if it's in a warm room. And the thing still works, but now it's registering slower. So they really should be recalibrated every once in a while. Why put one in? Well, if you've got a 30-inch chilled water pipe, 12-inch, I don't know, 12-inch meter is probably about $40,000. This thing will set you back $5,000. You don't have to shut the main. You don't need any space. You probably need about 30 inches on that pipe. So they're very popular. Again, now, the displacement meter is good for 95% of what you are doing. In 3/4 inch and 1 inch, you're probably looking at $200 a meter. If you're putting in sub-meters, that's what you want. You can come by them easily, and they're relatively cheap. So I'd go with those. If you get into larger sizes, above 2 inch, they don't make displacements. They make them, I wouldn't use them. Jump to the single jet, and if you got really large pipes, go for a clamp-on ultrasonic. Now here's the secret. Meters are more accurate the smaller they are. So if you want to bill, you want to be right, don't say, hey, I got a 2-inch line going to a small cooking area. Put on a 3/4 inch meter, neck the pipe down. It won't hurt you. It will hurt you if it reduces your water pressure. But as far as the accuracy, you could go for a smaller meter. Okay, enough about that. Meters. Does anybody have a BMS in their building? Your devices are read by pulse. So the entire industry, we live on pulse. We all live on pulse. Something goes by, let's say a gallon, and a pulse goes out. And you have something counting those pulses. And that's the way we've worked. So we have a motor spinning, we want to know the RPM, we have pulses coming out. Air handlers, we have pulses. The water industry, American Water Works, those are the people selling things to utilities, decided, hey, we need something different. Well, everybody needs something different. We're going to use encoded reads. Why? A homeowner, or maybe you, decides, I'm going to cut the line going to the transmitter on a meter. And the meter's in a pit that no one ever wants to walk into. So the meter read 1, 2, 3, you cut the wire, 2 months pass, you reconnect the wire, 4, 5, 6, and the utilities were finding out that they were losing water all over. They were losing revenue because people would really easy, cut the wire, put it back later. So that was one issue. The other issue was just noise in the system. They'd lose a pulse. Now, it might not make a difference to you on a piece of equipment if you lose a pulse for a few seconds. You got your read a little later, but to the water companies it was a big deal. So they came up with encoded meters. And what that means is the meter, all the meters I showed you, approved in the United States, are sending out encoded reads. Those reads, if the read says, if you look at the meter, it says 1, 2, 3, 4, 5, 6, it sends 1, 2, 3, 4, 5, 6 as a message, and then adds a time and date stamp. Today they're adding water temperature and pressure on newer meters. 10 minutes later it says 1, 2, 3, 4, 5, 7. It says 1, 2, 3, 4, 5, 7. You cut the line, a month later it says 2, 3, 7, 6, 2. That's what it sends. Now, this causes a problem because how do you unencode this read? And that's really your biggest problem if you go with non-pulse meters. Gets worse. Every manufacturer decided to come out with their own encoded format. So now you got a lot of meters. All those meters I showed you, each one has a different encoded register. So you've got a bit of a problem. But, you know, when there's a problem, somebody comes up with a solution. So let's jump ahead. What should I submeter? Anybody, what do you want to submeter right now? Is there anything? Any water you want to read? Yes, sir? In process equipment. Anybody else? Hose bibs. You want each one or all of them?
No, they're all on the same line.
Okay. So hose bibs are easy. Why? So you want it before the underground leak. Okay. Talk to me about that. This cheap solutions. Yes? Mechanical equipment. What kind? Chillers. Yeah. Those are the easiest. Those are good. So what pardon? A loop? Your fire loops. Yeah, no one notices when they're leaking. In most cases, a lot of towns don't even have meters on those, and they're really large sizes. So I was asked in New York City to write a code as to what we should monitor. And there were a bunch of environmentalists came out and said, we should monitor every single apartment, every single sink. I want all the data, everything in the world, yada, yada, because these guys don't have to do it. But what I find, you want to know equipment that's prone to leaks. If you have a laundromat, yeah, it's using a lot of water, but you'll probably notice if there's a leak. You'll see the water pouring. What you want to know is, do I have equipment that maybe uses very little water or a lot of water, but when it leaks, it's prone to a leak, and I probably wouldn't notice. The first is if anybody has these horrible single-pass air conditioning units or refrigeration units. A lot of buildings have them connected to a chilled water loop. And then the tech comes by to do some work, and he shuts the bypass on that. And now all of a sudden these things are running. And these things, they're little, you know, this is a 1-ton unit. They can use a crazy amount of water. So A, get rid of them. If you can't get rid of them, at least know what it is. Irrigation. Today, irrigation, if you haven't done so already, which I'm sure you all have, controllers, there's all kinds of equipment that can reduce consumption. So you do it all, and then a line breaks underground. We find that when we look at a golf course that has X number of heads, and we add up all the heads and how much flow they're supposed to have, the golf course is always using double. Where's the water going? Well, it's simple. There's a broken pipe. And it's not that staff's not doing it. It runs at 5 a.m. when no one's there, or right before dawn, before the grass burns out. You're irrigating the whole thing, and then a head breaks because somebody drove over it. Well, you get out there 3 days later, but you don't notice it right away. Cooling towers. Cooling tower controls, especially if you have a ball cock, are the worst. We go to buildings all the time, and the guy says, the cooling tower is using a lot of water. And I walk to the tower, and I see the water pouring down, just pouring. He says, we have a hole in the thing. I said, you don't have a hole. It's flowing over the pan. And I open up the hatch, I look inside, and I see the ball cock, the head, floating on the water, like it's dancing there. It's not connected to the thing, and the thing's running. And the guy goes, well, what's this going to cost? I said, I don't know, let's screw this back on, I can go home. We're done. But we see it all the time. Or somebody bends it. They just play with the thing. They're never working correct. If you have an electrical one, you're better. If you have two feeds, we see waves going across. One feed goes on, the wave runs across, and it turns it on because the thing goes up and then it's going down, and then they start doing weird things. Fountains. Well, what can you do about a fountain? We had a fountain in Manhattan on 6th Avenue. African Americans, a building, 1.3 million square feet. They had some designer come out, and he said, you know, the tower, that fountain would look better if the water didn't go up 20 feet. I think it should go up 40 feet. Okay. He says, doesn't make a difference. All the water pours back down, except that when we looked at it, on a windy day, nothing was going back. Once you went up to 40 feet, everything was all over the area. And all of a sudden, the fountain's using double the water. The Freedom Tower, they have, I don't know if anybody's seen it, but at the 9/11 memorial, they have these big pits that water pours in. They call me up and they say, we're using too much water. This was right when they built it. So I go to the engineer and I start doing a walkthrough. I've only seen the tower from underneath, the fountain, which is like looking at a big pool from underneath. And I asked the guy, well, when do you stop feeding it? He said, are you kidding? I never turn off. I always leave the drain open. Now I'm using less chlorine. Okay, you know, shut the valve and we go back home. Everything's good. He says, no, people complain. They don't like the smell of the chlorine. It's beautiful. It smells fresh. It's wonderful. Well, that was an easy solution. And the other place to put meters are places that have no leaks, no problems. If you can bill them, put a meter in. Really easy. Put a meter in, bill the people. And get the hot, if you're providing hot, try not to, because the heat in the water is at least double. The BTUs are double the water costs in almost anywhere in the country. So try to get them to provide a heater. If you can't and you have to give them hot water, put a meter on it and try to speak to your leasing agent or whoever wrote the lease and get 3 times as much. If you say you can't use the water, you can't use my hot water, I'm not letting you. Okay, so they use it. Now what do? Slap them on the wrist? Put it in the lease, they'll have to pay for it. So, you've been sitting here now for 35 minutes and I haven't told you how to do this. There's a lot of products out there and they really, not a major difference, but let's talk about the first one. Very simple. You buy an antenna and a collector. And there's a lot of them out there. When I say antenna, it can be a huge tower you'd put up for a town. If you have a mountain or something, put it up on the mountaintop of the building. But it could be a little teeny antenna on top of a computer. And all it does is each one of the meters have transmitters on them. You could do it with LoRaWAN, Wi-Fi. There's all types of other methods of getting that signal to the collector. And your meter, whether it's encoded or pulse, these devices will send a signal to a collector. The collector then takes the data and sends it via the internet to somebody that's going to clean up your data and turn it into bills, charts, whatever you want. So again, you need an antenna, you need a collector, you need to plug these things in. Very few of them are working forever on alternating current, right? You need a battery. You will need a plug it in, and there's a high upfront cost, and you're connecting to your internet. Well, you may say that's not a problem, and it might not be if it's your internet, but if it's in a tenant space today, they all show up and tell me, no. We have security protocols, we got this. You'll get there, but there's a lot of paper to fill out, right? Who wants to do that? And they have security concerns. I'm not sure what their security concerns are, but the minute you touch their system, you're in trouble. I tried putting one in an FBI building. Still hasn't happened. We tried putting him in for Google. No, you can't touch our internet. So that's that. The next is the people that say they have a BMS. Well, you can get this data connected to your BMS. Two problems. You have to get something that's going to take those encoded reads and translate them to your BMS. Second, you're going to have to run wires from each meter to your BMS. It's a lot of wiring. You know, if you're running this in conduit, I can't imagine. Imagine this hotel, you want 5 meters, one from the roof coming, and you're connecting to your BMS points. If they're nearby, it may not be a huge cost. You still have the encoded issues. Now, regarding the encoded issues, there are solutions, but your BMS provider probably doesn't know them. Every time I'm speaking to somebody with a BMS system, people managing this, they're like, oh, I can't deal with those encoded things. And then every meter's different, and every time I'm not dealing with it. So it's the best. The benefit is there's no transmission fees. You can get reads every second, and you now can see it all in the same place with all your other BMS feeds. The third solution, which, needless to say, we provide, but we'll do any of these, by the way, put in a cell phone-based transmitter. You can get these transmitters, it's cell phone-based. If you have cell phone reception, if you don't have cell phone reception, this is not going to work for you. If you have cell phone reception or repeaters or something, well, they built this system for you. So there's very low upfront costs, and they can run on batteries. They say they're 20-year batteries. I'm at year 11, and I'm replacing. But I got 11 years out of it, and I will tell you, when I put these things in, if you remember CDMA flip phones, that stuff's not, the problem is not the battery. The problem is my phone, that's LTE, is no longer reading those devices. Verizon no longer supports what I had, nor does T-Mobile, nor does anybody. So the battery is not your problem. It's the way technology moves. But they say 20 years. I figure 10. You'll be okay. Let me go back. So, if you're thinking of this, if you have 1,000 meters you want to read, somebody told you, I want to read every single apartment or every hotel room, go with a collector. Because when you jump to the phone charges, there will be a charge per meter. You're probably looking at a minimum of $1.50, minimum, $1.20. That's what utilities are paying that are doing this. So again, utilities, small utilities, 3,000 homeowners, they don't want to put up towers. They got a small town somewhere, 200 people, they're going for the cell phone. New York City, they built their own system. They've got 1,000,001 accounts. They don't want to pay 1,000,001 every month for cell phone charges. So they built their own system. They have a lot of control. But, you know, if you've got, I think the break is around 100 meters. More than 100 meters, it might pay to get a collector, if you can. If you can. So I'm going to jump now to what do you want to see? And I'm going to go through a few case studies. Chelsea Market is a building that has 50, you can see on the bottom picture, has 53 food stores, all provided with hot and cold water. They're using whatever they feel like. And on the top floors, there are a few companies you might have, when we put this in that you heard about, Major League Baseball, YouTube, the Food Network, Google, on and on. And when this building was built, Google put and YouTube put their lease, we only pay for measured utilities. They moved in, no one read the lease, this fine stuff, certainly not the engineer. And he says, I gave him the bill for CAM charges, for common use charges, and they said, nah, we don't pay for that. He said, what do I do? Back then, they were using about 300,000. Today, the prices went up. It's closer to 450. So I said, you're stuck. Are you going to repipe the whole building? He said, I don't know. I said, give me the lease. We looked at the lease. It said, Google will pay for putting whatever you want in order to have measured charges. So we spent 3 months, put in 170 meters. They said they wanted it done between 12 a.m. and 4 a.m., and we got it done, and we've been billing them for 12 years. You know, good things happen to these people. So right after we put everything in, Google bought the building, and now they're paying themselves. So I'm not really sure how well, but they are interested in the data at all times. So what do we provide them? We provide them all, that circle shows that pie chart, all the water being used by each and every store, the cooling towers, and there's one store that for some reason, a restaurant, I don't know, he's got water cooled everything and doesn't care. It's a high-end restaurant. They're using $130,000 worth of water every year. The other ones are using 3, and it, you know, just doesn't care, pays the bill, and the owner's happy. Somebody's paying the bill. And then each tenant gets a little bar chart with a line saying where they should be, and if they go over that, they get a notice that they have a leak or that consumption went up. The next one is a residential building. I'm not sure. They had a bunch of buildings, and they just wanted to know if the buildings are almost exactly the same. And what they found is the consumption, if you look at the orange, is much higher than the others. And they wanted to know. They didn't really care how much water their supers were using. They wanted to know that they're using the same amount. No one cares if you're getting ripped off as long as it's fair. The next is 55 Hudson Yards. This building wanted to bill everybody for everything. It's, I think, 65 stories, 1,003 feet, really simple building, no retail, all office. During construction, we put 2 meters on every floor. They have no tenants that are less than a half a floor. We're billing everything. And everybody gets, we notify them when they have a leak. We don't notify them of the dollar value because these people are using so little water. So we say, hey, consumption went up by 30%. We don't tell these lawyers, that's most of the tenants, that your water bill went from $7 up to 10 because they'd hang up on us. I don't know how many millions of dollars they're paying for rent, but we annoy them about consumption. The consumption in this building is down to nothing. And we put them on, because you asked, we also put them on the cooling tower. We did not put on fire protection. The next is Sloan Kettering. I don't know if you know Sloan Kettering. They are the foremost cancer research center in the U.S. They're, I think, 11 buildings, and they just wanted to know how much water is going into every building. This was not a complete success because they have bypasses between all the buildings, and guys are opening them and closing them all the time. The other thing is they are doing research, and no one will tell you what the research is, and no one's telling these doctors you can't have more water. So the guy opens up the water and lets it pour rather than, puts in reverse osmosis equipment. No one's going to say anything. And case study is 1500 Mission Street. They just wanted to build in San Francisco. They wanted to know how much water. This was just to bill the retail tenants. They have a very large gym. They have restaurants, etc. They wanted to bill those people, track them. We find leaks here every single day. Nice building, but we're only really dealing on the first 2 floors. Above that's, I think, office. I've never been to the building. And the last probably has more to do with you than anything else. This is a nursing facility. I'm not sure how many rooms. I think 300. But what they have is a bunch of buildings. Those are those blue lines. I don't know if you can make them out. And what this guy wants to know, what this owner wants to know, every morning, how much water am I using per bed, per facility? He's not interested in how much water the facility is using. One of these facilities only has 15 beds. Some have 700 beds. He wants to know per bed, what am I using per building, per bed? That's his primary focus. And he gets on, he sees it all right away, right there at his fingertips. He used to have each building, an engineer would read the meter, they'd fill out a chart, they'd send it to the central office. He's got all over the Northeast. I think he has some stuff on the West Coast. So we're reading all of these, and we just give him the charts he wants. On the bottom, we also read the cooling tower, and we give him an overlay. What he wants to really know is he had one winter where the cooling tower continued to use water. His cooling tower shouldn't be running in the water. Some cooling towers are running in the water. So he wants to see it goes down, and he wants to see consumption goes up with temperature or the dew point. So we're measuring that for him, and that's what he wants to see, because before that, this is one of the buildings where the ball cock kept coming off. And that's it. I'm open to any questions. I appreciate any questions. Anything? No? Okay. If anybody has any, I'll be around and I'll hand out cards. Thank you very much. I appreciate your time.